So with parametric equations, what we want to do is we want to try and relate two separate variables to a third. And what that is going to, for these, a lot of these equations, that third variable is time. So basically, a parametric equation is if you're looking in an xy plane, a pair of functions, an x equals a function of t and the y equals a g of t, which describes the x and y coordinates of the graph of some curve in the plane. And you can get all kinds of curves with these graphs. So if we have the two equations x equals t squared, if we have x equals t squared, and then we have y equals t squared minus 3, these are two equations, then what we want to do is figure out what that graph looks like. And in order to figure out what that graph looks like, we need values of t. So what I'm going to do is I'm just going to take this 2 right here, this negative 2, and put it in for x. So x equals negative 2 squared. And also, I'm going to put it in for y. So y equals negative 2 squared minus 3 times negative 2. Okay, so the x-coordinate then is going to be 4. The y-coordinate is going to be 4 plus 6, which is 10. Okay? So that's how you get all of these points. You're going to take your value for t and you're going to plug it into your x and y equation. So let's look at another one. What about negative 1? So x equals negative 1 squared, and y equals negative 1 squared minus 3 times negative 1. So this is going to be 1. This is going to be 1 plus 3, which is 4. So 1 and 4. And those are the points that we're going to plot. Alright? What about 0? So x equals 0 squared. Y equals 0 squared minus 3 times 0. So both of these are going to be 0. And then at 1, so this is going to be 1 and negative 2. And then the last guy. And so this guy's going to give us 4 and 4 minus 6, which is negative 2. So we can graph this out. And it's going to look something like this. So what do we got? 4 and 10. So woo, you know what? Let's just put a line. So here's our xy axis, and then we're just going to plot these points. So we've got the point 4, 10, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 4. And then 0, 0. And then 1, negative 2. And then 4, negative 2. So we've got this kind of curvy shape here. Something like that. Okay. So, but that's our plotted system. That's our plotted system. And I connected this parabola looking thing because it's about how the dots all line up. But if you're graphing this first one, that's what you do. And don't let this be hard, okay? You're going to evaluate each x for t and each y for t. Plot those points out on an xy number line, and then see what kind of shape you got. You can get all kinds of shapes. You can get curves, you can get circles, you can get ellipses, you can get straight lines, you can get a little bit of everything. Okay, so let's look at this example here where we're going to graph a program that a robot's been going to follow, and we're going to go from 0 to 5. So these are the t values we're going to check. We're going to start at 0, go to 1, then 2, 3, then 4, then 5. And just like on the previous problem, we're going to take the x coordinate and put it in for x, and put the y coordinate and put it in for y. And we're going to find all of those things by substituting the value of t in. So I'm going to have x is going to be 2 times 0, y is going to be 0. So this gets me the point 2, 0. No, I'm sorry, 0, 0. Woo. 2 times 0 is 0. And then I put a 1 in. So x is going to be 2 times 1. Y is going to be 2. So this is the point 2, 2. Shoot, 2, 1. I can't. All of a sudden, I can't think good. So 2, 1. Then I'm going to put 2 in. So x equals 2 times 2, and y equals 2. There we go. That's better. So that's going to be 4 and 2. And then 3, x equals 2 times 3, and y equals 3. So this is 6 and 3. So we're going to have 8 and 4, and 10 and 5. So these are the things that we're looking at, and we can graph these guys. And when we graph these guys, we just graph them on the xy axis. We just plot these points. Here's x, here's y. So when I plot these points, I go to the point 0, 0. I go to the point 2, 1. I go to the point 4, 2, 6, 3, 8, 4, and 10, 5. And so when I connect these guys with the line, I start at 0 and I stop at my last point. I don't go past my last point because my restriction on t stops me at that point. So here's what my parametric equation looks like. Now, we can rewrite this with a formula and create a function now without t that represents this particular guy. And if you'll notice, it's a straight line. It rises 1 and it runs 2. So it has a slope of 1/2. And I've got a point that's on that line. So I could go y minus 1 equals 1/2 times x minus 2. This is a good answer. You don't need to go any further. But you can make mistakes. However, if you're one of those people that likes to have nice, neat, orderly stuff and can't stand it, you could go here and stop. And again, you haven't made too many mistakes. Or you could go one more and stop here. So these are the 3 things that you've got. And again, it's not too bad. Okay, here's another one, and again the difficulty's ramped up just a little bit, so we're looking at sines and cosines now, which makes things a little bit more challenging. We want to describe the motion that's shown to us. We're going from 0 to 2 pi, and we want to eliminate the parameter. In other words, write a function equation with just x's and y's and no t's. So anytime I'm asked to graph something in trig form, I'm going to look at specific values. And So it's going to look like this. And to get my x-coordinate, I'm just going to put 0 in. So x equals 2 cosine 0. Well, the cosine of 0 is 1. 2 times 1 is 2. Now the pi over 4 part is a little bit tricky because it's not necessarily one that we know what pi over 4 is. This is going to be 2 times the square root of 2 over 2. Okay, but for what we're doing, we really need a good idea. And square root of 2 is not one of those numbers that I keep in my back pocket of just memorizing, although it is a good one to know. So just punch it into your calculator, and you'll see that the square root of 2 is 1.414. So go ahead and carry it out to 3 decimal places. And then at pi over 2, the cosine of pi over 2 is 0. And then 3 pi over 4, so when x is cosine of 3 pi over 4, then that's the same thing as 2 times negative square root of 2 over 2, which is going to be negative 1.414. Alright, and then pi and can you tell why I picked the pi over 4s and the pi over 2s? Those are easy ones that we need to know. And then if you are paying attention, 5 pi over 4 then would be negative 1.414. 3 pi over 2 is going to be back to 0. 7 pi over 4 is back to positive 1.414. And then 2 pi is back to 2. So those are my x-coordinates. Okay, those are all my x-coordinates. And then I'm going to do the same thing for y. So let's get rid of these x guys. And I'm going to do the same thing for y, except this time with y, I'll do y in blue. So I'm going to have 2 sine of 0, which is 2 times 0. So when x is 2, y is 0. Then I'm going to look at 2 sine of pi over 4. Well, that's going to be 2 times the square root of 2 over 2, which is 1.414. And then 2 sine of pi over 2, that's the same thing as 2 times 1. So when x is 0, y is 2. And then 2 sine 3 pi over 4. Well, that's the same thing as 2 times the square root of 2 over 2 again. And then when I'm around a pi, can you see the pattern? 2 sine of pi is 0. So, and then I'm going to be below the y-axis, so now I'm going to have negative 1.414, 2, negative 1.414, and back around to 0. So when I plot these points then, and I'll plot them in a different color, and I'll count 2 units, 2 boxes for 1 unit. So I'm going to have the point 2, 0. So 1, 2, 3, 4. So here's 2, 0. And I'm going to plot the easy guys first. Maybe we'll see. So then I have 0, 2. And then negative. Okay. Negative 2. This should be a negative 2 right here. And then the other one should be like right here like this. So there's my pieces. And then 1.14 and 1.14. So, you know, if I go 2 units, 1.14 is almost half, and up almost 1.5. So here's 1 and then half more, and then 1 and then half more, somewhere right around in here. And the same thing on the other side. And then down here. And then over here. And if you're, paying attention really close here, this is going to line up to form a circle. Okay? And so that's our shape. So let me make that circle a different color because we're going to talk about it for a second. So there's your circle. Okay? And how do you write the equation of the circle? Well, the equation of the circle, in case you may or may not remember, is x minus h squared plus y minus k squared equals r squared. So the radius of this guy is 2. So I want to be equal to 4. And the h and the k are where you're centered, which in this case is just the origin. It's 0 and 0. So I'm going to have x squared plus y squared equals 4. And that's eliminating the parameter.